past, you may have seen different approaches for solving quadratic equations. Here we're going to look at case 1 and case 2 using a method that I'm going to call Miss Chaffee's method for factoring quadratics. I'm just using her name because I know she teaches it this way. She also teaches it other ways. I just wanted to attach something to it. So we're going to go through this method with both of these, which you've already done, and we'll look at how it differs. It's not really that much of a difference. It's just one subtle difference, which some students seem to like. It might make it easier for you, especially if you don't love factoring, you're not very good at it. So both of these are going to start in the same way. So we're going to begin by multiplying a value here and the c value here, and we're going to throw that into this little x diagram that we used in the past. So we're going to do 1 times 12. We're going to put that on the top here, and then we're going to put the b term on the bottom here. And just like we did in case 2, we're going to think of two numbers that multiply to 12 and add up to 7, and we're going to put those here. So 3 times 4 is 12, and the sum of 3 and 4 is 7. Now we're going to draw a box. I've called this box the factoring rectangle. I just made that name up. I don't even know if there's a name for it. But this box is going to help us look at the structure of the multiplication of the two binomials that this is going to factor to. So in the first box here, I'm always going to put ax squared. So if I look at this, 1x squared I'm going to put here, and I'm just going to put x squared right there. This one down here, I'm going to put the c value. So the c value for this quadratic is 12. All right, then in these two spots, I'm going to put the two values I have here with the variable attached to them. So I'm going to put 3x in this box here. This diagram tries to show that. And I'm going to put 4x here. And you can swap these two. I could have put the 3x here and the 4x here. It really doesn't matter, just as long as they go in one of these two positions. All right. Now, we're going to look at the rows and the columns, and we're going to factor out the GCF for each row and each column. So I'm going to start by looking at this column right here. And I'm going to factor out the GCF for x squared and 3x. So if I look at those two, the GCF is x. And then I'm going to do the same thing for this column. So when I look at this column, 4x and 12, the GCF is going to be 4. Now I'm going to go down the rows. So I'm going to look at this row. So the GCF for x squared and 4x is 4. Or sorry, not 4. It's x. And then when I look at the GCF for this row, 3x and 12, I get 3. Right. Now, this is a positive 4, so it's understood that this is x plus 4. This is a positive 3, so this is x plus 3. So this is going to factor to x plus 4, and then x plus 3. You would set both of these equal to 0. So for our solutions, I'm not going to go through that at this point. We get x equals -4 or -3. I'm going to do the same thing with this one. One of the positives from this method is you're not really thinking of case 1 and case 2. You can do both of these as a single case. So I'm going to do the same thing over here. I'm going to make my little x diagram. I'm going to multiply 10 and 9, which gives me 90. And then I'm going to put the b term down here. And then I'm going to think of two things that multiply to 90 and add up to -21. So I end up with -15 and -6. Remember in the other video we made a list of the factors to figure that out. And now we make our box. In the first square here, I'm going to put my ax squared term, so I get 10x squared. I'm going to put c down here, which is 9. And then the two values that I came up with that multiply to 90 and add up to negative 21, I'm going to put those here with my variable. And then I'm going to factor out whatever I can in this first column here. So I can factor out a 2x. Look at the next column, I can factor out a negative 3. Then look at this row, I can factor out a 5x. And then if I look at this one, I can factor out a negative 3. Now one thing that you need to make sure you check is that when you multiply, you get the same values in this diagram here. So what I mean by that is 2x times 5x is 10x squared. Negative 3x times 5x is negative 15x. 2x times negative 3 is negative 6x, and negative 3 times negative 3 is positive 9. If you do not get the right signs, you might have to change some things to get it to work. And so what we got on the top is 2x minus 3. What we get over here is 5x minus 3. And then we would set both of those equal to 0. So this one gives us 3/2 as a solution. And this one gives us 3/5 as a solution.